Let's discuss this question next. The question says, in how many ways can the letters of the word permutations, okay, be arranged if the words start with P and end with S? Okay, this is the first part. Then there is the second part, vowels are all together. And there is another part, there are always 4 letters between P and S. There are 3 big parts, right? Let's see how do we approach this question over here. Letters of the word P and S and their vowels as well, right? So let's write all the letters of permutations first. Permutation P, E, R, M, U, T, A, T, T, I, O, N, S. You may see that T's are repeating and no other letter is repeating over here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total of 12 letters over here. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters over here as well. Yes, we haven't missed any letters and we have written the consonants and the vowels separately. One of the consonants is repeating, that is T is repeating. It's coming twice. Now let's talk about the first part over here. The first part says, in how many ways can the letters of the word this be arranged if words start with P and end with S? Okay, so starting with P and ending with S implies out of 12 you will be arranging 10 letters at 10 places, and therefore the number of ways will be equal to what? The number of ways will be equal to 10 factorial over, since the two T's are similar, we'll have to divide with the 2 factorial. Yes, this is 10 factorial upon 2 factorial. And what's that value? Can we calculate this value for now, right? Let's calculate this value. 10 factorial is 10, 9, 8, 7 and 6 factorial is 720. We remember that. This is divided by 2, right? What else? This is 4, okay, and this becomes 10 times 9, 9, 4, 7 and 72. So what we can do is let's multiply 7 times 4. 7 times 4 is 28. Okay, and 28 times 9, let's multiply that as well. 28 times 9 will be 280 minus 28, which is 252. This is 2520 and multiplied with 720. This is what we are supposed to do. Right, let's check that once again. 9 times 7 is 63, 126 and 252. 2520, right? Keep checking the products as well, right? So 252 multiplied with 72, that's what we are supposed to do, and let's do that product over here. 252 times 72, let's multiply them together. This is, we can do it over here only, right? 72 is an easy number, 252 are also easy. So we have 2 zeros at the end. 72 times 2 is 144. There's a 4, you carry forward a 14, okay? Then you get 360 and 14 is 374. 4 and 37 gets carried forward. 144 and 37. 144 and 37. So 44 and 37 will become 81. 181 is what I'll be getting. 1814400 is the final answer that I'll be getting for this part over here. Next, let us talk about the second part over here. What does the second part say? Okay, we can get rid of this. This is not required. The second part says that vowels are all together. Now what are we supposed to do in this one? The vowels have to be placed in a bag actually. P, R, M, T, T, N, S and the vowels. You see all the vowels are there. A, E, I, O, U, all the vowels have been correct. E, U, A, I, O. These have to be kept in a bag first of all, and this bag will be permuted with these other elements. What are these? 1, 2, 3, 4, 5, 6, 7 and 8. 8 in total, okay. So the number of ways will be equal to what? The number of ways will be equal to 8 factorial divided by 2 factorial. Why do we divide by 2 factorial? Because these are exactly same, right? These are alike letters. So we divide by 2 factorial. What else? These vowels which are placed in that bag, obviously they will be, that bag will be kept at one location, but the vowels have to be permuted, right? They occupy 5 places and they can occupy 5 places in 5 factorial ways, right? So the net arrangement will be this. That number of ways will be this. This and this both are required for finding the total number of ways. This is what you do. So what is this? 8 factorial times 8 factorial divided by 2 factorial. 8 times 7 times 6 factorial is 720. Okay. So this is 720 divided by 2 and 5 factorial is 120. This is what we have. Let's say this is 4. This is 28 times 72. Oh, 28 times 72. Did we multiply that? No, we multiplied 9 as well over there. But 28 times 72 times 12 is what we have over here. So let's multiply 84 and 288. What do we have over here is 7428. Can we simplify this further somehow? Somehow, yes. 144 and yes, 288. Which will be, what will be multiplied over here? 12 times 4 is 48. So this becomes 480. Okay, and 7 times 720. What is that? This is actually 0. 7 times 2 is 14. And this is 5040, right? This is a good product, right? 5040 multiply 504 multiplied by 48. Now that is what we'll be looking forward to. There are 2 zeros at the end. 2 zeros at the end. 48 times 4. What is that? That is 192, right? 48 times 4 is 192. So you have a 2 and you have a 9 as well. You carry forward a 1. 48 times 5 will be 240. 240 and 1 is 241 is what I get. So 241, 9200 are the total number of ways in this particular case over here, as you can see. This is the answer for this part over here, the second part. What happens in the third part? Let's talk about the third part after this. The third part says that there are always 4 letters between P and S. Okay, and there are always 4 letters, yes. So let's try to solve the third part over here. 4 letters between P and S, okay. P and S can be interchanged, right? The positions can be interchanged, but since we have total 12 places, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, which places can P and S occupy? Now, please observe which places can P and S occupy. That's the important thing that we want to note over here. So, P and S can occupy, if you see, this, if P occupies this, then S will occupy, there are always 4 letters, this place will be occupied by S. But then this is one particular case, right? If, let's suppose, P occupies this one, so S will occupy this one in that case, right or not? Yes. Okay. If P occupies this one, then S will have to occupy this one. And similarly, you'll have an alternative case where S occupies this and P occupies this. Okay, S occupies this, P occupies this, S occupies this, P occupies this. Basically, these two in between these 2 places, S and P can interchange their locations. That is possible. But how many possible locations are there for selecting this first one? So we can select this one, or this one, or this one. If you want to select the last possible combination of P and S, so we'll have to go 1, 2, 3, 4, 5, 6. This is the place, right? If P comes here, 4 places, and this will be the location of S, alright, corresponding to this one. So 1, 2, 3, and so on. You can allot this particular place to P, and correspondingly you'll have a place for S as well. So you'll have 1, 2, 3, 4, 5, 6, 7 ways, 7 ways of selecting positions for P and S, right? So 7 ways for selecting positions for P and S, and then P and S can also be interchanged among those positions, right? So you place P and S in these many ways. Now what you have done is, at those 12 places, you have seated P and S such that there are exactly 4 places vacant between them. The 4 places and the remaining 6 places have to be filled. The 4 places and the remaining 6 places have to be filled by the other alphabets, other letters over here, other than these R, M, T, T, N, A, E, I, O, U will fill those places. And the number of ways is something that we have already seen, haven't we? Yes. Number of ways will be this: 10 factorial over 2 factorial. Oh, that's pretty simple. Yes, that looks simple, and that is simple. This is actually equal to 14 times this number and something which we have already calculated in the first part. Let's use this 1814400. This is what we have. Let's multiply them together. This is 00. 14 times 4. Now what is that? 56. You get a 6. You carry forward a 5. 14 times 4 is 56 plus 5 is 61. you have a 1 and you carry forward a 6. Okay, 14 times 1 is 14 plus 6 is 20. You carry forward a 2. What is 14 times 8? 14 times 8 is 112 and you carry forward a 2. So 114 and you have an 11 carry forward. So 14 times 1 is 14 plus 11 is 25. This is 25401600 and yes, that is the answer for this third part. As you can see behind me, this is special and this is important, right? You have to select places for P and S. Out of those 12 places, first select the places for P and S such that there are exactly 4 places between them. Then arrange P and S between those places. The number of ways is 7 times 2. But after that, you also have to arrange the remaining 10 letters at the remaining 10 places. This is the way of doing that. This 2 factorial comes here because the T's are repeating and we have used that number from there. This is the answer that I'll be getting for this question. Is that all? Yes, that is all in this question. And with this, we come to the conclusion of this exercise based on permutations and combinations, actually permutations only. And in the next video, we'll be talking about another exercise. Till then, see you.